I fixed it. I just opened the meeting. There was a yellow button for me in the top, and now everyone could join.
Okay, thank you. Perfect. Sorry, it's my first time, I think, as a webinar organizer and not just a normal workshop or meeting. So, yeah, perfect. We even have 2 times Stefan Müller and okay, we have everybody. So welcome. Yeah, some other people are coming, so maybe we can begin at 10, if it's okay for you.
Yes, sure.
I can also begin with my presentation, and the most important are our guests. So I begin just with what I have to say about Europe and possibilities of funding, and afterwards I will let our guests take the microphone. So yeah, this is our agenda. And so I will just do some super small updates about funding. And afterwards, we will begin with ASEAN Plus. A lot of people are coming. So ASEAN Plus will be presented by Nora from EPMS Fraunhofer or Fraunhofer EPMS, and also from Georgios from Tyndall National Institute. And afterwards, we will have the possibility to learn more, like concretely, thanks to Stefan, Thomas, Alexei, Emmanuel. Stefan, CTO from FMC, Ferroelectronic Memory GmbH in Germany. Thomas, head of metrology wafer business by Chipmetrics in Finland, but Thomas also is in Germany. With Alexei, COO from Pauline, we will also learn an experience from England. And with Manuel, we will learn also a kind of academic experience from University Stuttgart from Germany. So yeah, I will begin with the funding opportunities. So just for all of you, the participants, at the end, this experiment, like as we will talk about ASEAN Plus, but ASEAN Plus exists thanks to this European funding programs. And it's just to let you know that everybody can apply to a funding program, and you can find on the European portal for tender and fundings a lot of possibilities, but there are a lot of portals, and this is just a reminder of the portals that you can find to apply to some fundings program. Yeah. So this is an example, but like the next fundings open call that are already open or that will open, and you just have to navigate on the portal and to find what could be a good program or a good project for you. If you can join a consortium, if you already have some contacts for consortium, you can join easily. If not, you can just start from scratch, and depending on the technologies you have or the ideas you have, it takes time, but it's really it's worth it. This is an example of an open call. It's Eureka Cluster 6, and you can have a matchmaking meeting in Hamburg. Okay, it is in 10 days to understand more about Eureka and what they do. And you still have time at the end of January to submit like the project objectives. You still have also other programs like Network Project, Eurostars in the framework of Eureka. So these are just examples. Actually, since at least 2 years, you have CHIPS joint undertaking calls. And in July, they announced a big amount of money. And I just recommend you to go on the website because you can find a lot of possibilities. Exactly. And I wanted to show you also, yeah, another call. Uh, it's like yeah, it's in the framework of Photon Hub Europe, and it's like a coaching possibilities with trainings, with skill development, with business coaching, with like test before invest opportunities. And you can have like a project like just you have already a prototype and you want to level it up, or you can already have a kind of early stage startup and you can even upscale with some budgets that I can give to you. So I really recommend also the startuppers here maybe today in the meeting to have a look at it. It's interesting. Now I just go back in one of our projects that is similar to SN Plus, because at SN Plus it will be the end, I think, like in February. And for us, it's even, and for you, it's even the end of SN Plus, like in September, so at the end of the month, because afterward we cannot accept anymore some inquiries. But we have another project similar, like the little brother. It's in Friendship. So with InfoShip, you can also have get access to some research institutes, transnational access to some I don't know either consulting from already researchers that are in these research institutes, or access to a lot of possibilities like clean rooms or microscopic technical ideas, or even to some workshops, or even to some summer school, depending if you want to send one of your PhD co-workers, or if you want to send like a product that you want to develop or to test, or an hypothesis in semiconductor industries. So there will be also some InfoShip workshops that I will reshare with you after that. But now we are on ASCEN Plus. So this is ASCEN Plus. The deadline to apply is in September 2024, so at the end of the month maximum. And today I will let our speakers talk about ASCEN Plus. So we begin with Nora. Exactly. So Nora, I have your slide that I will share. Yeah. And
Great.
I
Thank you.
will let you explain. So thank you, Nora, for being there. And I
Will
have the
you make it
slides.
full screen?
Yeah. Okay. Thank you,
Perfect.
Nora. I let you.
Yeah, thanks. Yeah, being part in this workshop, I was a little unsure what to talk about and how deep to explain, as the deadline for application is soon. I'm not that sure if it's really end of September, as the project runs until February next year. So maybe it gets a little longer, but for sure it's in the end of the project anyway. So I will just give what I learned about the project, and what's the possibilities for my institute to join, and how we did, and how we maybe will take part in the project also in the following half year. So first slide, exactly, about the ASCEN Plus project. I was joining when the project already ran. So I quickly learned about the project, what it is about. So it's a really nice European consortium of the big and the small players in the nanoelectronics semiconductor industry for research. So it's having two parts. It's one that we, the European players, work together, and not just everyone focuses on his or her own focus, but exchanging, talking to each other, get to know each other a little better. And the other thing is that the small universities, SMEs, have the chance to get in touch with us as Lady, IMEC, Fraunhofer, Tyndall, INL, and so many others. So it's those both things, and I really appreciated personally the working or get to know the other players in the field, but also being open for the small ones, as normally our business is working together with the big fabs. Maybe on the next slide. And the project gives the money for this this contact, these first small projects. So a big focus of the SN Plus project is the transnational access small projects. And there it's if you are a researcher on a university and you have an idea that you want to try out, or you want first measurements or first contact with those big players here, where you have the icons, then you can write your question and say what you think or what you plan to do. And then the one who is fitting best gets in contact with you, and you together fill out a form, which is really not a big deal. It's, I think, 3 pages, some small questions. It's not a big draft or proposal you need to do. And then it's checked if it's not, if there's some sense in it. And then you have the chance to have, I think, 4 weeks of cooperation funded by the European money. And this is really nice first contact. So maybe it's a small project, then you can already complete it within those 4 weeks. If it's something bigger, then it's at least a first contact, a first try if your idea is smart at all, or so it's a good entrance in this whole thing. It might be a base of future projects. Next slide. So this so much about the Aspen Plus program, and then Fraunhofer is part of this project. And Fraunhofer, it's always complicated because here on the map of Germany you have all those points where its institutes located, and they deal with so different topics. And then we have more than 10 in the microelectronics field, but it's still, they're spread and they have different focus. So for someone who's not inside Fraunhofer, it's really confusing. So I like the idea of FMD, so Forschungsfabrik Microelectronics. We try to gather it, and if you have a question, you can email or call Forschungsfabrik, and then we will internally see who is the best partner. So some of the Fraunhofer institutes are part in this ASTEM Plus project, and we try with the best fit to support the questions and to answer the questions and support your needs. On the next slide, maybe. So where I work, it's in Dresden at the IPMS. And there we are nearly 500 colleagues. And we have 2 clean rooms. So one 200 millimeter clean room and one 300 millimeter clean room. Yeah, next slide. And the location where I work in, it's the 300 millimeter clean room location. And there it's, Dresden in general is a nice location because it's a lovely city. But in the north of Dresden, you have a lot of fabs and semiconductor industry. And we are really in the middle. So next to us, we have Global Foundries. Then we have Bosch on the other side. We have some kilometers away, we have Infineon, and probably soon the ESMC fab as well. So it's, because we are close to them, it's really easy to exchange and to meet in person and to exchange wafers. So our daily business is research for them, for the big fabs, because they need to produce. and they don't want to try too much and to risk. But we can play around in our fab. Next slide. So our location, this is just a scheme of our clean room. So we have different parts there. So what we are good in is the thin film deposition. So ALD, CVD processes, PVD. And for those very thin films and materials, layers, we need the metrology, we need cleaning, etching, logistics, of course, and we have our own lithography and also our own VPD, so trace analysis lab in the clean room. So it's very similar to the fab. We have the same tools, but we are not producing. So we can go to each tool and play around with the parameters. And this is the biggest content what we are doing. So when there's a need of exchange of a chemistry, we can do it and try and modify the process as long as it's good, until it's good, and then it can be transferred to the fab. But it's not the only thing that we do in the clean room. Next slide. So what I was explaining, and I think what's easy to understand, is the screening fab. So we do similar to what a fab can do, play around with the parameters, and when it's the result is there, it can be transferred. But we also do back-end offline integration. We try to develop better and smarter ideas for non-volatile memories, for low power devices, and also for the trends, for the future technologies to be equipped and to have methods ready for neuromorphic computing, for quantum computing, and spintronics ideas. What is needed in the fab, which materials need to be developed, how can we characterize it? And in the grayish, in the down, what's for all those processes always necessary is the analytics, or the electrical characterization of the layers and the analytics. This is the advanced surface characterization, is the team where I am responsible. So this is what I know best. In the next slide, I go a little deeper to one of those topics, the NVM topic for those non-volatile memories. What are we doing in this field? So we have the 300 millimeter processors, and sometimes we also adapt it to 200 millimeter wafers. Some of the tools can handle both. Sometimes we use those insert pocket layers, pocket wafers. And then we try out new stacks, new materials, how to integrate the processes, and then we characterize it. We go to the electrical lab and see what's the difference now when we modify the process in the clean room. And we also try to give the circuit design for this. Next slide. So NVM, it's a little, it's already established, and then we play around only, let's say. But for quantum computing, it's more new. So we need to test even more. But it's the same topic. So we have new materials that we deposit, and we see, is it easy to get a stack? Is the delamination playing a role? Which parameters do we need to tune? And how can those materials be included in the CMOS line? How is it thermally? Are there new problems with the micromagnets, for example? So many topics that needs to be discussed before it goes to the production, to the market. So really, in the first step, we try to be a little ahead of what the fabs need in the next years, to already know how to deal with those materials. So it's not that we do quantum computers already, but we do the pre-studies. And And then we have the analytics. So it's both in the clean room, the metrology, and outside the clean room, we call it the lab analytics, the PFA, where we have nice tools where we can, in the labs around the clean room on coupon level, do electron microscopy and see how thick a layer is or how the interface was. Or we can, with X-ray techniques, with XPS or with XRD, we can check the crystallinity and the chemical behavior or structure of the layers. And then we try to give the feedback to the colleagues, and then we tune again, and we have many loops to improve and get better and to know about the material. Yeah, and then we are pretty new is our new VPD analysis lab that we in the clean room can check the quality of the clean room, which is really important. And this is also a need for smaller customers. Yeah, so I explained a little what we do and how we could support other partners. In the beginning of the SM Plus project, I think the idea was that small customers can use the clean room tools, but for really small customer, the clean room is far off of their daily work. They do it in lab scale. But our lab analysis is useful for everyone, and also some of the processes in the clean room can be useful for potential partners or clients or customers from the SM Plus project. So much from me.
Thank you. Do you have some questions to the audience? You can ask your questions to Nora.
Or later on, also fine.
I have one question, Jonas here.
Hej, hej.
From Alix Labs. Hej, hej. Så, vi kan prata svenska. If you want to continue on a project out of Ascent Plus, is there some opportunity to do so, or is there some maximum if you want, because I know there's a deadline end of September, and I'm thinking if we should apply for a follow-up project, is it possible?
We should, as we already had a project, I think a follow-up project, we could make it until the end of September to submit it quickly, to have the chance to do it until February. But for new customers, I think it will be really tough to do it within 3 weeks. But I also think that now as the contact is made, well, we knew each other before, but for others, that if you somehow find someone who can support you, of course you can work together in future. That's the meaning of getting to know each other and learning about how can it be, how is shipping, what's the contamination issues, and all those small tiny things that you need to learn before a cooperation can be smooth.
Okay, yeah, so I will reach out to you like tomorrow.
And I will double check with the steering board if it's really the end of September, or if now that we have it, the written confirmation that the project is until end of February, maybe we will extend it a little.
Okay. Yeah, that would be very nice, because we had success with the first project, so we would like to do a second learning cycle, basically.
Would appreciate.
Thank you. Thank you.
You're welcome.
Okay, if there is any other questions, we can continue. Okay, so thank you, Nora, for your time and for your presentation. Oh, sorry. So now we will let Georgios Fagas from Transnational Institute to present his program.
So let me see. Just a couple of points to check first. You can see full screen my presentation.
Yes.
And you can hear me fine. Okay, thanks. Thanks, Leticia, and thanks, Nora, for the introduction of the program and for organizing this. My name is Joros Fagas. I'm based at Tyndall National Institute in Ireland. I'm there head of one of our research programs called CMOS++, and also the EU programs. And I had the responsibility and to put this program together and lead it as a coordinator. And I hope I can give some answer also to the last question of where Ascent Plus is at the moment and where we are heading post Ascent Plus. You can see there the consortium that has been brought together now almost 5 years before the program started exactly 4 years ago. But of course, as a consortium, we existed, in the proposal phase long before that, and also this is the second phase of such a research access to research infrastructure program. Before that, we had Ascent on its own, and the premise of this program is really to bring together providers across Europe of research infrastructure, and make that available for transnational access, as Nora very well said. And within Ascent Plus, we don't only have the 5 access providers, SEA, Leti, EMEC, Fraunhofer Microelectronics, as was described before, and the International Iberian Technology Laboratory, and ourselves, Tyndall. But we also have 5 what we call academic or knowledge hubs, academic research organizations that we work together to enhance what the innovations and the offer that we put forward to the users. And then we have also 4 community networks that help us to reach out to the community, to the micronano electronics community, and also make the spread the message across their members. Now, we all know that making things is not easy. It's challenging. It requires many nice ingredients, many things to get right, from advanced equipment to platform technologies that have taken tens of years of development, and also it takes people with deep knowledge and expertise. And this is what this 10 million euro investment by the European Commission tried to achieve, to bring those together and offer a catalog of technologies, expertise, and advanced equipment to the European research innovation community, but also outside Europe as well. I'm not going to go through the explicit complete service catalog, which has over 70 items in the showroom. Here is the link to that. What I would be saying is that essentially what we managed to do, and I think is to bring this infrastructure across the access provider together and integrate to provide a toolbox for driving micro and nanoelectronics innovation in Europe. As Nora mentioned, the example of a Fraunhofer Microelectronic. Imagine if you are how difficult it is to navigate between the various institutes. Imagine now if you're a researcher in a remote area in Europe, and you're trying to navigate yourself among the various research and technology infrastructures, and you like to get access to advanced equipment, platforms, and expertise. And this is what we managed to do through Ascent Plus. And these are some examples, and top-level examples of what we offered. And the key point is really to make access easy for the users. So, and the user can be anyone from academia, research organization, or industry, SMEs, and large enterprises as well. And I'll come back to that a little bit later. And it doesn't matter whether you know someone or whether you know exactly what exists in these large-scale organizations. We do have a virtual showroom for you to see what is available through the Ascent Plus, and also we have an access interface team that takes your inquiries and questions about the access, and mediates these to the technical points of contact to each of these organizations to see what is feasible and what is not feasible, without you necessarily knowing exactly, which person sits in that corridor and what tool is available in that research organization, research technology organization. And the point is to try to get these, as Nora mentioned, these short scale project feasibility type studies that can lead to other projects, preliminary data, or validation of certain processes, materials, or methodologies. And if I'm to take let's say our position where Ascent Plus is in the overall innovation pathfinding diagram, I would say we're looking at these challenge-driven research and prototyping type of projects, or actually projects that leads into the technological proof of concept, the technological feasibility, some demonstration of technology prototypes, and a small scale development. And this then feeds into the larger scale initiatives that exist in Europe and can be taken, at the next stage. With this in mind, the Ascent Plus program funds is completely 100% at no cost to the user, short-term projects, and to increase the profitability, especially for SMEs. It offers access to the exclusive equipment, to the platform technologies. I had a few of them presented or shown in an earlier slide with the Ascent Plus toolbox, and also the extensive expertise to these well-known European research and technology organizations. And also it can be used as a springboard to partnerships, ensuring the full IPR protection. I heard the question and before about what is happening next. There is of course the possibility to do Ascent Plus, and I'll come to that in a moment. But also there is the possibility to look at other schemes to collaborate with each other. And we had within the last 4 years of the Ascent Plus program running, we had several examples where we did a feasibility study through an Ascent Plus Transnational Access project, and then based on that study, we established either direct collaborations, or we applied for European and national funding to develop further the technology. So coming back to the question of whether there is still time to apply for transnational access, indeed, the project has been extended till February next year, and we are going to issue a final call for access within September. The deadline is last day of September. Now, the reason for that is that we need to ensure that there is enough time between the evaluation of the proposal and the project end to carry out that work. Now, in the meantime, if there is a small project that require little of work, we will always have a look at it if it comes after the September deadline. But to ensure that the projects or your proposals will be evaluated for sure, and will be given a priority within the research organization's capacity over the next few months. I believe one should try to apply within the next few weeks by the end of September. In terms of outputs, so far we had the 135 projects that we have committed. These have benefited more than 550 researchers across 32 countries. And what is also very important is that 20% of that access has been offered to industry, and specifically 17% of this is directly to SMEs. Now, if you have an inquiry, of course, please go ahead if you had a previous project and discuss directly with your technical point of contact and how to carry that through. Otherwise, I would suggest also to put an inquiry directly on the website, or write an email directly to our Access Interface contact, Nicolas Cordero. What happens after Ascend Plus? And Leticia actually mentioned that at their introduction. There is a follow-up program to Ascend Plus. There is some overlap in the technologies, but technologies do and do evolve, and this means needs from the European Commission and European users do evolve. So in this new follow-up project called InfraChip, European Research Infrastructure on Semiconductor Chips, is a 15 million almost euro investment by the European Commission. We have rejigged the technology platforms and the access providers to enlarge the offering. Again, the program is very similar to Ascend Plus, same conditions apply. The way we have structured it is across 5 different themes, 5 different pillars: the power pillar, the sense pillar, the think pillar, connect, and sustainability pillar. And within there, we have several technology platforms that address the technologies, technology platforms, the equipment, in order to be able to innovate across those 5 different pillars. One key, let's say, differentiation with respect to Ascend Plus is that here within this consortium and enlargement, we include thin film, printable electronics, and also we are looking at the sustainable materials based on advances based on sustainable materials and sustainable processing. And that's it from me. If there are any questions, I would be happy to take.
Yeah, feel free to ask some question to Georgios.
I hope I also answered the previous question clearly.
So yeah, the end of the application is the deadline is at the end of September.
Yes.
So if you don't have questions, I continue with the case study testimonials. And we will begin with Dr. Stefan Müller, CTO from FMC.
Yeah, hi everyone. I hope you can hear me.
Yes.
Okay, good. Then I'm first in line to give a little bit of feedback on our experience on the ASCENT Plus. We ran a project with Leti, and I will lead you through this in the next 10 to 15 minutes. So let's go to the next slide. So first, a bit about FMC. So we are a company based in Dresden, Germany. You know the cluster, which I show on the top right-hand side, which was mentioned previously by Nora also. There are lots of semiconductor companies in Dresden, around Dresden. We are located in the northern part also of Dresden. We are, as FMC, a spin-off from the University of Dresden. That's what's shown on the lower left-hand side, aiming to commercialize ferroelectric hafnium oxide for memory applications. So this is a material innovation for a novel type of data storage. We have, over the past now almost 7 to 8 years, grown to 42 full-time employees. We have our main offices in Dresden, which you see on the top left-hand side, and we have also a small office in Milano in Italy. And our expertise is in the field of ferroelectric material development, ferroelectric memory design, electrical characterization, and product development. The team you see on the lower right-hand side is only a fraction of the team. And yeah, please continue to the next slide. Okay, so the ASCENT Plus project, when we applied for it, the background here was that we have been collaborating with CEA Leti in the past and also today on the development of our novel ferroelectric memory technology. I gave you here also a publicly available link to an EU project that we currently are running with Leti as one of the partners. And one of the goals of the project was to establish a procedure to insert wafers from FMC's tool vendor partners into the fab of CEA Leti. So you can think about it this way. We have partnerships with tool vendors for deposition of thin films. The memory stack we are developing with these partners, and it gets deposited at the tool vendor site. Then we take those wafers, ship them to Leti. And as a third step, we need to do a contamination check at Leti that we can insert those wafers in the Leti pilot line. And finally, once this check is successful, we can insert it in the pilot line and do some processing of those wafers. And I will explain in the next slide, in the upcoming slides, what type of processing we did there. And that was here the second goal was to do actually patterning of our thin films at Leti. So we had two goals. First, to establish this insertion procedure, and then to pattern our films into smaller capacitor structures. And why did we choose Leti as a partner? Because Leti is offering already, you find this on the EuroPractice website, the so-called Memory Advanced Demonstrator. This is a so-called multi-project wafer, where people can go to Leti, hand their design to Leti, and they will run wafers which have advanced memory technologies on them. And Leti also, so this was of high interest to us for future projects. The second reason why we chose Leti was that they have, of course, 8-inch and 12-inch processing capabilities. And the development of our memory stacks that we do with tool vendors, that happens on 12-inch. So we need essentially a partner that can do 12-inch in Europe. And the last reason, that's the last bullet here, is of course that Leti has many, many years experience with memory technologies, and that also qualified them well for what we aimed to do. Okay, next slide, please. So as I mentioned, the first part of the project was to establish insertion procedure for external wafers. So what you see here on the left-hand side, these are the external wafers that we processed at our tool vendor partners. These have a stack of different layers. You see them in color coding. So we have basically a bottom electrode in yellow, then the ferroelectric material itself, followed by a top electrode and another titanium nitride layer. And then these wafers had to be inserted into the Leti fab that you see in the second picture. There we had to develop a defect inspection first that qualified these wafers to be clean. And then once this was successful, Leti did a hard mask deposition. We used this hard mask for structuring the wafers with lithography. So first a hard mask etch was done. That's the third picture here. And then with this hard mask, we were patterning the ferroelectric layers into small capacitors. And we verified if this worked successfully by metrology, so by SEM, for example. And the success of the project was ultimately judged then on the metrology, which was also done at Leti, because Leti has a lot of metrology capabilities. Okay, we can go to the next slide. So what was the result of the project? So it was a very good outcome. All the goals that we set for the project were actually achieved. We successfully could verify that we can introduce external wafers from tool vendors at the Leti fab. And the second goal was also achieved, which was that we could verify that the memory stacks that we have developed with our tool vendor partners could be successfully etched into small capacitor structures at CEA Leti. And if you ask me about improvements to the overall project, I can identify very little, to be honest, because everything went as planned. And also, as mentioned before, the application procedure was very straightforward, and also the grant approval was super fast. And this really is quite important for startups that where time is critical. This was really nice. And based on this project results, what we are now doing as next steps is to continue our collaboration with Leti within publicly funded projects. So that kind of was started in parallel, and successfully we could enter into an EU project, which I referenced already before. That's the so-called Ferro for Edge AI project. And in this project, which now has, of course, a much bigger volume and a larger consortium of partners, we can benefit from these learnings that we gathered in the Ascent Plus and can continue developing our memory technology. Ultimately, this Ascent Plus project is a small contribution to our overall goal that we ultimately want to transfer our technology into high volume manufacturing of a foundry or an IDM semiconductor fab. Of course, we've seen the timeline just in the talk before. This is at the end, right? The Ascent Plus is more at the beginning. And now we are kind of in the second or third phase of these development cycles. And ultimately, Ascent Plus can be a small piece here that could help us in entering into the next phases. Okay, that I think was it. Yeah, thank you very much. And if there are questions, I'm happy to answer.
Thank you, Stefan. Yeah, if you have questions, the audience, if you have questions to Stefan, please take the chance to ask your questions.
Yeah, maybe I'm asking a question. I'm Burkhard Sluschka, co-founder of Allo Semiconductors, also in Dresden. Would you support my observation that this is actually a kind of qualification, vendor qualification project? So you wanted to know whether you can work with Leti. Leti wanted to know whether they can work with you. And you found a way in this project to actually very hands-on to test that and to get public support for that. With the outcome you described, everything went well, which was exactly the achievement you wanted to have.
Yes, and I would go a little bit further. So we achieved actually more the qualification of, let's say, the vendor being able to collaborate or bring in wafers into the Leti fab was one part of the project. And that was successful. But the other part was also this etching of the stack, right? And the etching, this went beyond the vendor qualification. This had as a goal, we were not sure if the materials that we were using with the tool vendor were so easy to pattern into nicely structured capacitors, because we were using materials that are a little bit harder to etch than the standard materials. And that was actually to us the major outcome, because it was a real technology outcome which enabled us to proceed with Leti. Because if the outcome of this second part of the project would have been bad, we would have known, okay, this type of memory stack that we have developed is not possible to be patterned at Leti, and then we would have had an issue to continue collaborating with Leti, right? Because they would not have had the edge capability. But this verification that their edge capabilities are suitable for our capacitors, this went beyond the pure vendor qualification.
That is really interesting for me, because so why is that interesting? It's, I would say, not as something I would really describe as in the narrow sense R&D, but in a very positive sense. A broader definition is applied apparently here, which is actually, I guess, excellent news, and very often something which indeed happens in R&D. But especially in my experience in public funding projects, it's more expected to promise something more fundamentally, so something closer to an inventive step, actually, than in testing successfully a working hypothesis you guys had.
Yeah, it's in principle, so it is not, let's say, was not a groundbreaking activity, but it was a fundamental activity, let's say, that we could, with Leti, I mentioned, for example, before that multi-project wafer approach that Leti has. So this project or this project outcome now enables us to use Leti as a partner to actually fabricate real memory chips that incorporate our memory stack, because we can pattern the memory stack at Leti. And that is, Yeah, I agree. It is really further along the path towards prototyping.
Yeah. If any maybe quick questions, quick answer if you can at all. First, maybe I missed that. How long was that project? Secondly, do you have any idea if you wouldn't have got a grant, but if you would have needed to pay Leti for that, because that's real work what they have done, right? How much would it have been? So what was your saving? And then maybe, I don't know whether you can answer that question or other people in the call, how typical is that kind of example you gave for the overall program?
Yeah. So on the project duration, I can state, I think I would have to look it up, but it was rather quick. So once we applied, I think after 1 or 2 months, we got the approval. And since we knew Leti, we could start very quickly, and we had the results, I think, after half a year or so. So the overall project duration, I think, was around half a year. Regarding the volume of the project and how much it would have cost us if the SN Plus project would not have happened, this answer I cannot give because we never received a quotation from Leti. We only handed in our application, and they judged, okay, how many wafers can we run to do this? And that's all I know, right?
Okay.
Yeah. And maybe someone else in the call could answer this. I think Nora, maybe she can comment or so.
Thank you.
Maybe if I understand, Burkhard, I can take the last part of the question is how often we may get or the project that the SN Plus program supports are further up the, let's say, the technology readiness levels, right? And they are not really fundamental R&D. Is that rephrasing your question? Yeah. So
yes, I think that's accurate.
Yeah. So typically, I mean, there are 3 evaluation criteria of the proposals that are put in. One is the feasibility, the on technical grounds, whether the project makes sense. Then there is one on what you could call research excellence, or this new element, and then there is another on innovation, and we just about. I mean, the review panel looks at this across all these 3 criteria. And some projects are stronger on the new idea, some others are more stronger on the innovation side. When it comes down to something that is coming from the SMEs, of course the expectations are different, right? So we look at how important that project is for the SME, and whether it would make sense as to take them further down the journey of prototyping, and then qualifications or further development through a pilot line. And if that link is clear, then of course the project is going to be granted. Maybe I should also say that a lot of work goes up front when there is discussions with a technical point of contact. So our success rates are 96-97% once a proposal gets in. Good.
Impressive. Thank you.
Thank you. Are there other questions? Okay, so we can continue. So thank you, Stefan. Now it's time to listen to Thomas from Chipmetrics. Thank you, Thomas, to be there, and it's your time.
All right, thank you, everybody. So my name is Thomas Werner. I'm head of metrology wafer business of Chipmetrics. We are, next slide. Yeah, so we are a young company, I wouldn't say startup, from Finland. We were founded in 2019. Actually, we are a spin-off of VTT, and we are based in Joensuu. This is a smaller town in Finland, like about 450 kilometers from Helsinki. But we also do have an office in Dresden now, and we have a total staff of 12. And what we do is metrology chips for semiconductor manufacturing, especially in the field of highly conformal thin film deposition. We have a worldwide customer base in the industry as well as academia. And yeah, we are experts in like 3D film conformality measurements. So on the next slide, a brief introduction of why this 3D conformal coding is so important, and that has to do with the fact that it becomes more challenging to maintain the Moore's law advances, and that means we need to look for a new solution. One of those solutions is the third dimension. And so we see a lot more like 3D devices currently under development, already on the market, which is, for example, 3D NAND flash memory, capacitors of all sorts, but also more and more advanced packaging solutions. And all of these technologies require very highly conformal film depositions. And this is usually done via atomic layer deposition, or ALD. And one of the problems in manufacturing these specific structures is how do you know what you processed? You know, how good was your conformality? And on the next slide, the typical way would be performing cross-sectional analysis, which could be SEM, or for advanced structures, more likely TEM analysis. And this requires, first of all, very advanced equipment. It is time-consuming, and time is money in semiconductor manufacturing, and it is also expensive. Yeah? And this is only an option for like very high volume manufacturers, and still it's a couple of hours until you have your feedback. And our approach to that is based on the fundamental performance of ALD deposition, that it doesn't really matter if it's vertical or horizontal. So basically you can transpose from a horizontal structure to a vertical structure and extrapolate the film deposition performances. And for that, we developed, that is on the next slide, our core product, that is the so-called pillar hall technology. And the chip is called lateral high aspect ratio, LHAR chip. And what we do here, these chips contain membrane structures, and under these membrane structures are cavities or gaps from 100 to 500 nanometer gap height. And now the film is deposited on the wafer, and there will be a certain penetration depth into this gap, which is shown here by the blue film. And now instead of performing cross sections, you just remove that top membrane. The top membrane is just supported by oxide pillars. That's where the name pillar hole comes from. So you just put some tape on it. It's shown at the bottom left. Peel off the membrane, and then you can easily, and that's shown on the top right, view the film font. Can measure all sorts of parameters of your film depending on what you have available or what you want to see, and then you can measure your penetration depth, and from that you can extrapolate back to your target structure which you want to qualify. So that's basically the story behind it, and we've been selling these chips for a few years now, and there is, however, one problem or one challenge, and that is on the next slide. So our chips are made with very specialized MEMS technologies. Those are not made in 300 millimeter fabs. So our chips come from off of wafers of 6 or 8 inch wafer size. However, the target leading edge fabs are obviously 300 millimeters. So the challenge is, how do we make or turn 150 millimeter wafers into 300 millimeter wafers? And for that, we envisioned the pocket wafer approach, which basically encompasses a 300 millimeter wafer with so-called pockets. So these are like rectangular areas which are etched into the wafer, and the chips will be placed in these pockets, and then they can function like a 300 millimeter and can be handled by regular manufacturing tools. So this is this was the next evolution or a key step in gaining a wider market acceptance and making this available to customers who were previously out of reach for us. And this led to two related ASCENT projects. First one I'll show you on the next slide. Yeah, so here we started with a what I would call a feasibility study. This was part of that was finding a manufacturing method, and also did do some initial studies on suitable bonding methods. And here we partnered with Fraunhofer IZM Asset in Dresden, which is a advanced packaging or backend fab, and produced some pocket wafers, so developed the technology for that, and did some initial screening of possible bonding materials, and we found a material that was okay for the first demonstrations, and we were able to get stability up to 350 degrees, which is okay for the beginning, and we produced some demonstration wafers there, which we were also able to present to potential customers. So this was the first project. So it, considering the resources available, it did what it was supposed to do. So we manufactured these pocket wafers, and we did some initial studies on what could a bonding method look like. However, this was still not at a maturity level where we could offer this as a regular product. And this had to do with the some adhesion issues of this material, and also the limited temperature budget. Plus, Fraunhofer IZM acid, as mentioned earlier, is a backend facility. However, the target applications for our wafers are usually in the front end, and wafers which were in a backend line can never go back to the front end due to the contamination concerns. So that's why we applied for a follow-up project. This would be project number 2 on the next slide. And this was more focused on industry compatibility. And here we focused on contamination levels and also doing some first demonstrations with real ALD processes. So here we switched the manufacturing approach of the 300mm wafers to a method that is compatible with front-end applications. So this was done with the help of an external vendor. Partner was Fraunhofer IPMS, or basically Nora's team. And we also developed the bonding method further to a outgassing-free material, which has also a much higher temperature budget. And we ran some first ALD film depositions and showed the results of that at the ALD for Industry conference in Dresden in March of this year, and also at the ALD-ALE conference in Helsinki at the beginning of August. So with this, we are now in a position where we can have serious conversations with potential customers, because this is now a solution that has some degree of maturity, where we could cooperate with advanced wafer fabs and offer them wafers which are compatible with their environment. So in conclusion, summary on the last slide. Yeah, so from our perspective, Ascent Plus is a very beneficial platform if you are SME and you want to accelerate product development. It is a relatively uncomplicated application process, and there's access to really good resources across the continent, and also the human capital that is available is pretty amazing. And it also helps building networks that will exist beyond the time of the Ascent project. So in our case, we entered a close collaboration with Fraunhofer IPMS that is ongoing till now, and there will be more future projects. And it even led to us expanding to the Dresden region. So we are currently in the process of setting up a German subsidiary. The process will be completed in October, and that would not have happened without Ascent Plus. Maybe I should also mention I actually started this project. When this project started, I was still on the Fraunhofer side, and then with this project, basically decided to pursue my further career with chip metrics, so that we can even have that benefit. So for us, the experience is somewhat positive. There's always room for improvement, and of course, that can be the timelines. So obviously, the R&D partners across Europe, they also have other projects to work on, and that can lead sometimes to longer project times than expected, which is not unusual, but one should be aware of it, that it may not always happen within the timeline that one had planned for. yeah, that's pretty much the end of my talk. Are there any questions?
Thank you, Thomas. Yeah. Do you have any questions? Feel free to ask to Thomas. Okay. So there's no question. I continue with my slides. Thank you, Thomas, for your time and
Yeah.
presentation. So now we will listen to Alexei from Pauline Technology.
Well, can you hear me well? Hello?
Yeah, it's perfect. Yeah, we can
Right.
hear you.
Good afternoon, everybody. And thank you for inviting me for this meeting. We're happy to share our experience with Ascent Plus. So let me just start with introduction of the company and our technology and what we are doing. So you have a better idea and how we benefited from Ascent Plus project. Please, next slide. All right. So we have Bristol-based published chip company. We have a team of 40 engineers and business professionals. Yes, with major office in UK. We also have a team in Israel and in the US. And well, yes, we are fabless, and so we need some partners to fabricate our chips. Well, basically, we are working in a very interesting area. Can you please go to the next slide? So we're addressing the issue with a huge amount of sensors coming to the use. Some people say that it's going to be several tens of trillions of sensors in the coming years. This is a huge amount, and this all generates a lot of data. And well, our goal is to address this issue with our technology. Next slide, please. All right, so well, as I mentioned, we are developing and fabricating chips. This is analog neuromorphic chips. So our approach is to sit as close to the sensor as possible. So idea is to do a lot of reprocessing at the sensor level. So we reduce substantially a need for sending data somewhere else for processing. So in addition to this reduction of investments in infrastructure and requirements to process data, we are, well, basically bring a lot to customer level in form of well, longer battery lifetime, because we don't need to use all of this energy for radio. In addition to that, we basically reduce bill of materials because we can eliminate a few devices, few components in the major devices. Well, basically we are very inspired by brain in terms of the way of processing data and energy efficiency, and we do use neural networks to provide this functionality. Can we see the next slide, please? We start with artificial neural networks. So whether it's designed and developed and trained by us, or we can utilize somebody else's developments and collaborate with somebody. But at the end, the starting point, we have a trained neural network, right, that we are going to place in our chip, to the piece of hardware. And in most of the cases, we have always hard-coded in the chip, but in some instances, we can allocate a few percentage point of neural network capabilities for digital part to provide some sort of flexibility if needed. But all energy efficiency, all power savings, all the data optimizations arranged in a fixed area. Right, next slide, please. So basically, we use a standardized design flow. As I mentioned, yes, we getting trained neural network in the beginning, and then we have some in-house know-how transformation. So first we do transition of this neural network into a specific form, which gives us a netlist, and then we use the netlist to finalize chip design, and then GDS goes to a foundry to fabricate a chip. So basically, you see that we have two major components in our know-how. This is math and some know-how in hardware. And about hardware, we'll talk more a little bit later. Next slide, please. So with this technology, we are going after three major markets. So first is vibration and monitoring, and so we place our chip in small IoT devices, battery-dependent devices. Second area is audio. So basically, we work with a noisy audio signal. First, we just detect human voice and do some and provide some capabilities to end user devices, how to utilize this knowledge, I mean, detecting of human voice. Also here we can extract human voice from noisy audio and provide better talking and listening experience in noisy environments. I think everybody experienced some issues with conference calls and just calls when you're in a noisy area, like flow of exhibition or in a public area. And if you need to talk to somebody, sometimes this is quite challenging. In our case, we can extract human voice and communicate it to other parts without bothering your counterparty with noisy audio. The third area is wearable devices. So this is mainly about digital health and early vital sign detection and monitoring. So in all of these three cases, we're talking about from 2 to 3 billion units annualized volume in terms of chips and devices. So this is the area of our ambition and magnitude of our ambition, and the area of implication of technology we developed by help of SN+. Can we go next? Right. Basically, in our case, we collaborated with Fraunhofer IPMS, and thank you to them for their support. So it was kind of a transnational case. So we tested tantalum nitride deposition, right? And our goal was to develop a process and test it in an environment which is close to industrial scale. With Fraunhofer IPMS, we found this capability. So we gained an access to PVD, and eventually, thanks to IPMS, we developed a very important part in the process to fabricate our chip in a proper way with the proper parameters. Next, please. Well, what we learned from the program? Well, yes, I just can align with the previous speakers. Yeah, this is a very unique program in terms of application process. So this is a really easy thing to apply to. Aside to that, so basically, well, as a startup or a small company, you have quite a big challenge because on one hand, you would like to be on the market as soon as possible, but on the other hand, you don't have a proper volume or purchasing power to attract industrial players. So you can't just go to, I don't know, regular, so to say, foundry, asking them, okay, could you please fabricate a few wafers in 300 millimeter process, which is quite well complicated, costly, and frankly, it's quite challenging to find anybody to talk to you in this area. So that's why it was so important for us to meet Fraunhofer IPMS with industrial scale tool, and we enjoy relying on their tool of 300 millimeter. So later we found exactly or very similar tool in other facilities, in industrial facilities. So in this case, we had quite easy, at least internal way to communicate to others, right, about application of our technology in industrial scale. The second area and benefits of collaborating with IPMS was, well, available metrology. So we met in some instances that, okay, somebody may have a tool, to do deposition, but well, there was a lack of metrology. And luckily, IPMS has everything under one roof, and well, and it was accompanied with very well-trained researchers. We don't need to bring anybody from outside to do this job, to do any application and measurements. So we fully rely on Fraunhofer IPMS capabilities to do this project. And of course, we enjoyed great connections of Fraunhofer within industry. And frankly, we continued our journey with IPMS well towards full commercial deployment of our technology. Well, this is pretty much all I wanted to say today. So should you have any questions, I'm happy to answer them. Thank you.
Thank you, Alexei. To the audience, would you have questions to Alexei? Okay, so we will finish with Manuel.
So, hello
Thank you.
everyone.
Yeah. I'll let you
Do you
share your.
see
Yeah, perfect.
my slides? So you see it?
Yes.
Perfect. So, hello everyone, and thank you for inviting me as well for this talk. So here, as I said in the beginning, I want to give a basically very application-oriented insight in a project where we use the ASIN Plus funding. And yeah, the project was basically to design a gallium nitride IC for wireless power systems. At first, I want to introduce myself a little, very shortly. So I'm a research assistant since September 2021. I work at the University of Stuttgart in the Institute of Robust Power Semiconductor Systems. My research areas are basically the power electronics and of course based on gallium nitride technology. And here I do applications like power module design, also wireless power, high frequency DC-DC converter, yeah, and a little bit of modeling. Also at first, the institute has a wide research area where semiconductor technology is on the one side, and on the other side are power and microwave systems. So we have basically everything in between those areas. And we have two groups. One group is basically on the RF side. So here are terahertz, gigahertz communications, the topic, or yeah, multiphysics, BEOL, on wafer measurements, and so on. And of course, my area is the power electronic, where we do some modeling, do characterization of wide bandgap gallium nitride or silicon carbide MOSFETs. And my area, of course, is in the range of the gun hands, smart power modules, and of course 3D integration. So it's more at the bottom, so basically application-oriented subsystem design, and yeah, a little bit integrated circuit design. And we had basically an idea for a project where we wanted to build up, or we had the idea to build up a very extremely compact and cost-effective wireless power transfer systems. And for this, we worked on a self-oscillating Auroya converter, which is an oscillator, so it switches in its own resonance, which is basically defined by the resonance tank CP and LP. And of course, here the inductance LP can be used for the energy transfer in a wireless power transfer system. So at first we had this circuit with discrete components, and the new or the novel idea of this motivation of this project is basically to use the transistor circuitry monolithically integrated, use gallium nitride technology for higher efficiency, megahertz switching frequency, and of course reduce space. So as you can see with the self-oscillating converter, we don't need any active components or controlling. It's everything self-regulated. And therefore, when we look at that circuitry, we can basically reduce the part count of the circuit by a lot by just incorporating those transistors in one chip. So with basic or with the idea and the gallium nitride technology, we had one problem: we don't have a technology. So we came up with the ASN Plus proposal to basically get access to IMEC 650 volt gallium nitride on insulator MPV run or MPW run. And this was basically made possible by ASN Plus. So we proposed for funding and get the access to the 650 volt gallium nitride technology, where at this point the technology, especially the 600 volt version, was very new at IMEC. So they got some characterization of the transistors and the technology, and we got basically chip area. And of course, we did the design, we handed in, and after a little bit of time, we got back with, or we had basically the chip back, and we could build up our systems. So one big point or opportunity of this circuit is that you can use it as an inverter and rectifier at the same time. So we have basically both systems on both sides, and we therefore could also reduce basically the cost. At the bottom, you see also some design evolution where we go from silicon or discrete silicon devices to GaN devices, and of course then to a very small GaN IC package. And here it was, of course, the focus to be cost efficient. So we used also some PCB coils, which get at higher frequencies in the megahertz range more and more efficient because the Q factor rises, and therefore we could use them. And with the chip, we get into the frequencies of up to 3 megahertz, where we then, of course, could transfer energy. So the chip design was basically 2.5 times 2.5 millimeters. Could reach up to 650 volts, but due to the coil design and the system we designed, we only needed basically 100, 150 volts. Yeah, we reached a frequency of 3 megahertz, and with that frequency, we achieved a 90% efficiency, transferring power of 55 watts. And we could also go with a lower frequency, of course, to higher powers, where we see on the right. So we could go up to 100 watts, but this was basically the very upper limit of the chip. Yeah, and we could improve the frequency by a factor of 6. So the whole systems, which is basically, or the size of the system, which is basically dependent on the frequency, could also very much decrease. So we had a very high power density, and of course, a very good efficiency. When I talk about efficiency, we talk about the DC input to DC output. So everything is basically included. And yeah, this is also published in a paper at YPDA in 2023. So when you have interest, you can look there. And at the end, of course, the funding through ASN Plus was a very good opportunity, of course, to get access to the 650 volt GaN on SOI technology, to get a feeling how they or how this technology works and how they perform. And yeah, as all the other talk or all other presenters say, it was a very fast project. Acquisition and support was perfect. So yeah, that was very great and perfect for PhD students which are or which need to get access to a process or equipment which is not direct available in-house, to get basically access to such advanced technologies. And of course, thank you very much for all the supporting persons at ASN Plus and IMEC to get this project running and to a very good end. Thank you very much.
Thank you, Manuel. Would someone of you have question to Manuel? Okay. If nobody has question, it will be the end of our webinar. Just maybe to say, like, do someone of you have kind of questions for all the webinar, like maybe to the other speakers? Okay. So yeah, just some two last slides. Silicon Saxony, we are present at Switch. It's an event in Singapore, like Semicon, and you are also present at Semicon Europa. And during these events, you can network a lot, and we still have some tickets. Oh, sorry. For Semicon Europa on our main stand. So if you want to join us, it will be a pleasure. Just contact me and I can arrange that for you with our event team. And now I just have to say thank you to all for your participation and to the guests for your talks and your presentation.
Thank you, Leticia.
Thank you.
Thank you all.
Thank
Thank you
you.
all. Thank you.
Thank you.
Bye-bye.
Thank you. Bye.
Bye-bye.
Enjoy your evening. Bye.